All right, welcome back. We're going to move on to section 3.10 today. Make sure you put your name and the date up on top of the paper. Our title for today is we're going to be talking about products of mixed numbers. Now, if you will recall, this word products should immediately make you think of multiplication. If I can spell multiplication correctly, I'm going to start over. That was terrible. And because the products are the things that that's what we get when we multiply. So that's the answer. When we multiply. So for a long time we've been multiplying things like 2 times 4 is 8, and recall that means we're going to have two groups of 4. So that means I do 1, 2, 3, 4, 1, 2, 3, 4, and I get 8. Well, it gets a little bit trickier when I take this old style of multiplication and I start using it for fractions and mixed numbers. And we have a specific way of how we use those things when we are multiplying fractions or when we're doing mixed numbers. So, for example, say that we are trying to make some of my world famous Mr. Dan's bread. And the bread recipe tells us for 3 loaves, we need for 3 loaves, we need, let's see, 4.5 pounds of flour. But I don't want 3 loaves. So instead I'm going to be making 2 loaves. So the question is, if I have a recipe for 3 loaves, but I only want 2 loaves, but I know that 3 loaves needs 4.5 pounds of 4.5 pounds of flour, then I need to know how much flour for 2 loaves. And we're going to use multiplying fractions to solve this. Because if 3 needs 4.5, and I only want 2, 2 is 2/3 of 3. So I can just take 2/3 times 4.5 to solve that problem. But we haven't quite learned out how to do those things. So we're going to have to come back to this in a moment. First, let's write down our rules and our steps for multiplying fractions. Step number 1, we're going to multiply. Actually, my rule number 1 is instead going to be turn to improper fractions. Step 2, multiply numerators. Step 3, multiply denominators. Recall that the numerator is on top of the denominator. Then we simplify. And you may need to do step 5, and you may need to rewrite as a mixed number. Let's take a couple of examples of this before we go back and see if we can solve the problem of the bread. Okay, let's take a look at this. Let's do our little example one. I'm going to flip to a new page because I'm almost out of space. Example one. We're going to take the product of 1/2 and 4/5. 1/2 times 4/5. So following my steps, it kind of looks like this. First thing is to turn to improper fractions. Well, I don't need to do that because I don't have any mixed numbers in here. I only have fractions, so I'm good to go already. The next thing I need to do is multiply my numerators. Okay, so my numerators are the top, so I have 4 times 1, which is 4. Third step, I'm going to multiply denominators. 2 times 5 is 10. So I've got my answer, 4/10, but I have to do my next one. Step 4 says simplify. So I should look at this and ask, is there anything that I can fit into both of these numbers? Well, whenever they're both even, I know that I can fit a 2 in there. So I'm going to divide top and bottom by 2, and that's going to give me 2/5. And I know that I'm not going to be able to simplify that because 2 is prime, so I'm good to go. I've got my answer of 2/5. And notice how I followed my steps in doing this. Let's look at another example real quick. Example 2. Let's do 3/5 times 7/11. Okay? So I'm going to do the same thing that I did before. First, turn to improper fractions. Oh, well, I'm good. I don't have to do that because I don't have any mixed numbers that I need to break up. Next thing, multiply numerators. Okay, 7 times 3 is 21. That's one of those facts I should probably know. Next thing, multiply denominators. Okay, 5 times 11. That is one of those facts that sometimes people know, but it's kind of easy to think about. It's just 11 5 times, and every time you add 11, both of the digits stay the same. So I end up with 21/55. And I can check and see, is there anything that is going to fit into both of these? Well, 3 and 7 both fit into 21, but none of those fit into 55. So I am fairly certain that that is simplified. So I'm good to go, and I kind of checked. Let's take a look at another example. Example 3. Now this time I'm going to add in some of those mixed numbers so we kind of know what to do. Let's take a look at 5.5 times 2.5. So when we're going to do this one, we are going to need to do that first initial step. And our first step, remember, was to turn to improper fractions. So that means I need to take these and turn them into just fractions. And recall, to do that, I multiply the number outside of it by the denominator and then add it to the top. Kind of looks like this. I would do 5 times 2, which is 10, and I would add it to 1, which is 11. So I would end up with 11 halves because I did 5 times 2 plus 1. Right? And this one I would do the same thing. So I would do 2 times 2 plus 1 over 2. And this is 5. So I have 11 halves, excuse me, times 5 halves. Now that I'm done with step 1, I can go on to my normal steps. So I'm going to kind of combine 2 and 3, multiply numerators and then denominators, because I kind of got the feeling for that. Numerators, I've got 11 times 5, which creepily again is 55. And then I have 2 times 2, which is 4. And I have to check and see if I simplify it. So now, 55/4. Well, the only numbers that fit into 4 are 1, 2, and 4. And those don't fit into 55 because 55 is odd. So I am good to simplify it. But this time, I need to rewrite as a mixed number. So I'm not totally finished yet. And the way that I would rewrite this into a mixed number, remember, is trying to figure out how many 4s are in 55. Because every time I take 4 away from the 55, I can pull one of those holes out of this number. So for that, I can just quickly do a little division. 3. So this time I would have 13, remainder 3, which means I'm going to have 13 out front, because that's how many 4s fit in, with 3 left over. And that left over, I'm not going to turn into a decimal like I was before. I actually want the remainder this time. And that's going to become what I end up with above my number over here. Okay, I'm going to do a couple more, and then we're going to return to that original problem. Example 4. Okay, let's take a look at this one. We're going to do 3.5 times 2, oops, a big 2, and a third. Okay, so again, my first step, if you recall, make sure I'm on the right part of the page, is that I need to turn these into improper fractions. And the way that I do that is I multiply the number out front by the number on the bottom, and then I add that product to the top. So this would be 3 times 2 plus 1 over 2, times, I'm going to do the same thing here. 2 times 3 is 6 plus 1, 2 times 3 plus 1 over 3. And if I was going to rewrite these, I could say that this is 7/2 times 7/3. Okay, now I can do it. Now I'm set up with my improper fractions, and I'm ready to go. 7 times 7, that's a perfect square. I should definitely know that. And that's going to be 49. 2 times 3 is 6. All right, let's take a look. 6, can I fit into anything? Now, 49 is one of those weird numbers that very few numbers fit into it. And 7, I believe, is the only one, aside from 49 and 1, of course. So I think I am set to be simplified right here. But I'm not done, because simplify is step 4. I need to then rewrite as a mixed number. So I need to figure out how many 6's go into 49. So this might be one where I have to do a little bit of guessing and a little bit of figuring it out. So I know 6 times 6 is 36, 42, 48. 6 times 8 is 48. Okay, 48. So now I can pull 8 of those 6's out, which leaves me as 8 and 1/6. Because if I was going to set up my little division, I would do this, 6 into 49, and I would have 8, remainder 1. 6 times 8 is 48, with 1 left. Makes sense? So my answer is 8 and 1/6. Okay, I'm going to do a couple more. Actually, let's go back and return to our flower problem that we had in the beginning of this set. Now, instead of looking weird, this should look really easy. Because I'm going to do it small, because I unfortunately didn't think to leave myself enough room. Let's do 2/3. And if I'm going to turn this 4.5, I can do 4 times 2 plus 1, which is 8, 9. So I can do 9 halves. So then I can do 2 times 9 is 18. 3 times 2 is 6. So I have 18/6. Before I'm going to pull out my mixed numbers, though, I am going to simplify. So this I can just turn into, well, actually, if I divide by 6, I get 3 over 1, which I can really simplify as 3. So my answer is that I'll need 3 pounds of flour to make 2 loaves of Mr. Dan's famous recipe. Okay? If you feel like you get it and you're good to go, then you can stop taking notes here. I'm going to do one more example if you'd like to take notes. Okay? Let's go with example 5. Let's see. Let's take a look at this one. We're going to do 18/20 times 4/9. Alright, this one's kind of big, so we need to do a little bit more math in this one. I don't need to fix any improper fractions. I'm going to just multiply my numerators, 18 times 4, which I can't do that one in my head, unfortunately. So I'm going to do 32 so I end up with 70 2. 20 times 9, well, that's easy because I can just take off the 0, do 9 times 2, which is 180, which is 18, and then add my 0 back in. So I have 72 over 180. Now I know that's not simplified because I can certainly at least divide by 2. If I divide my bottom by 2, I've got 90. 72 divided by 2 is 36, I think. Yep. Again, I can divide by 2. And that, I'm going to move down because I'm out of space. 36 divided by 2 is 18. 90 divided by 2 is 45. Now I've got, I can divide by 9. This one's going to simplify quite nicely, it looks like. And I have 2/5 for my final answer. All right. Good luck on the homework. If you have any questions, find someone to ask. Good luck.